Hi and welcome to number 3 in the series for H4 plugins. We're going to be looking today at GPIO functions, and for the first time we're going to be getting into the actual code and the kind of thing that you are going to be writing when you do this yourself. So here we are. I'll come to the code in a moment, but just let's look at the hardware first. ESP8266, a very bouncy tact button on GPIO 0. My standard testing traffic lights, we're only going to be using the red one, which is the line that's on D6. So let's look at this code. Now, because it's the first code that we've seen, I'm going to go through it in a little more detail than I normally would. Future videos aren't going to go into as much detail. So this first line here must have that, all sketches. Also, you must have this line here. 115200 is the speed of the serial monitor for watching things. This is the size of the H4 queue, which you should just leave as the default, and we'll talk about the others at another time because we just want to get started now. Now what we're going to do, here we are, look, here is our first GPIO code. We're going to have what we call a raw input on GPIO 0, and a raw input just passes every single 1 and 0 to H4 plugins. It does nothing with it at all. It's a totally raw output so that you can see what happens with a really bouncy switch. So we need to see something, so here's our second GPIO. We've got an output. We're calling it red LED. It's on pin 6. It's active high, which means that when you put a 1 on it, it makes it light up. Starts in the off state. The button, just to go back one, is active low, which means that when we get 0 volts on it, a low signal, that's when it means it's been pressed. So make sure you know the difference between active low and active high. The rest of the code here you're going to become very familiar with. Oops, daisy, that's my new tool I'm not very good at yet. Do excuse me. Didn't mean to obscure it all. I meant to do this. Okie dokie. Right, this is what we call an event handling function, because everything in H4 and H4 plugins pretty much is an event. Something happens, this is the code that gets called when that something happens. The something in this case is a GPIO event, and that is signified here by the type of event name. And what we get here is we get the pin number and the value of the pin. So they're always strings. You don't need to understand why, but the first thing we need to do is to convert the string into an integer value. Same for the value of the pin, and then we go through a switch statement, because don't forget we can have many inputs. So this is how we decide on how to react for each different input. So effectively, by the time we get here, we're saying there has been an event, which is a GPIO event, and it was on pin 0, and here's the value of it. Now then, we then take whatever the value was and we set the output LED to it. And all of that together just makes the LED do exactly what the value of the input pin is doing. The reason we use logical write rather than what you're probably more used to with a digital write is because once we've told H4 whether a pin is active high or active low, then a logical write will turn it on or off in exactly the way you would expect it to do it. So you don't have to keep thinking, oh, this is an active low, I've got to set it to a 1 or a 0 or whatever. If you want it on, you logical write it on. You want it off, you logical write it off. As long as you get the declaration correct to start with, then the rest of the code works. All right, let's see it happening. Now, watch two things. Watch the LED and watch the serial monitor window. And I'm just going to press the button once. Okay. Not sure why we didn't get anything in the serial monitor window there. Oh, we did. That's why, because it was off the screen. My apologies. So, do you see what happened there? Look at that. Look at that. That's what's called bounce. I'm going to clear that window and let you watch it again just to make sure that we know what's going on. Okay, that time we got no bounce. We pressed the button, it went down, it then came up. Let's try that again. Oh, there we go, look. One press, you can hear the click probably, can't you? See if I can do it when I let go. No, that's nice and easy. Sometimes it works like a well-behaved button. You press it, you get a signal, you release it, you get a signal. A lot of newcomers expect that that's the way that buttons always work, but you can see here that they don't. A single press can result in many 1010 transitions. Let's keep doing it and see if we can see it happening. Oh dear. Isn't it sod's law? I was doing some experiments with this exact same button one time, and on a single press on one occasion it bounced 37 times. And here am I having a problem getting it to do it once for a demo. But that's the problem with bounce. No, 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 no. It's a little bouncy. I really want to make this happen. I'm going to stab it as quickly as I can. No, no. Oh, there was a bounce there. Look, it went. I stabbed it gently. It bounced twice. Let's try that again. That's much more like it. Now then, what we're going to go and look at soon is a debounce button that'll stop that happening, and that's the kind of thing that we're aiming for. But if you want the absolute raw value coming through, raw is what you need. Do all of the YouTubey things, you know, like the video, subscribe to the channel and click the bell notification icon, because here's the thing that other channels don't tell you. Every time you don't do all of those things, a chip lets out the blue smoke somewhere.